Welcome, everybody. My name is Jordi Ricard, and it's a pleasure to introduce the fourth session of our Journey to the Cloud series. Today, we will talk about Dremio after the previous sessions about Microsoft Azure Synapse, Google Cloud Platform, and Amazon Web Services. You can find them online in our website and social networks, so you can reply them if you didn't have the chance to attend. With that, it's my pleasure to hand over the session to Oscar Martinez, head of our Big Data and Cloud practice. Oscar, can you share the highlights of this series of webinars we are preparing?
Sure, Jordi. Thanks for the introduction. So yeah, today is the fourth session of this Journey to the Cloud series that we have been conducting throughout the year. On the first three sessions, we saw basically we dedicated them to the main public cloud vendors and how you can build a data lakehouse and or solutions for data platforms on these platforms. The first day we saw Manuel Mas, and we listened to Manuel Mas explaining how we could build a data lakehouse with Azure Synapse and the rest of services there. On the second session, Victor Colomé showed a real customer project that we have been working on in the last years with Google Cloud and BigQuery, and we also show some tips on how to optimize a platform in Google Cloud. The previous session back in mid-September was delivered by Esteban Bosch, and he also showed another customer project that we have been working on the last year with AWS. So today is the day of Dremio. So today we're going to be focusing about Dremio. Alex will talk more about this, but before that, as Jordi said, we are honored to have today with us Amit. So Amit will be giving an introduction of Dremio before we explain you a real use case with this cool technology for data lake housing. After Dremio, we intend to have other sessions on Snowflake, Cloudera, and Oracle Cloud, but those will probably be already next year. For Snowflake, it might be that we have a separated series since we want to cover a few topics with Snowflake, but that's for another day. So today, let's go with Dremio. So thanks Amit for joining us, and all yours for you.
Hello, everybody. My name is Amit Manor, and I'm happy to join this webinar with our partners, ClearPeaks. I'm calling today from Israel, and in Dremio, I run the partner organizations across EMEA. So what I want to share with you in the next couple of minutes is talk a little bit about what Dremio does and what is a SQL Lakehouse platform. So for those of you who are not familiar with the term lakehouse actually combines out of two words. The first one is data lake, and this is something that has been here for the last couple of years, where organizations predominantly store high volumes of data in a very easy way, very cost-effective, and obviously the ability to scale infinitely. And house comes from the word data warehouse, which has been in the market for the last 30 years. And that's obviously where organizations will perform analytics. And the term lakehouse is basically talking about getting the capabilities of a data warehouse to the data lake. And what Dremio is trying to solve is basically the ability to run high-performance analytics directly on the data lake. So let me share with you some of the challenges that we usually meet when we talk to customers. So on the left side, you can see what most organizations today are trying to achieve. And that's obviously data democratization, give the ability to the end users to access the data, to get the insights, and basically perform the right analytics without needing to go back and forth to the IT. Obviously, support more initiatives which are data-driven. Time to value is basically what everything is trying to achieve here is get faster time to insights and really fast analytics. And obviously not to forget security and governance. So how do we make sure that people see the right data? How do we protect the data? And that's basically some of the challenges that organizations are trying to achieve. And you would expect by now that in 2022, this would be very easy. But the reality is that data is increasing in a very fast manner. Obviously, more and more organizations are asking by the team to get access to the data, but obviously the budget is not being increased in the same manner. And then obviously it's very hard to find the right talents. So with those challenges, Dremio was brought live somewhere in 2015 and have been in the market since 2017. And over the last years, we have managed to raise quite a lot of funding, which brings us to a unicorn or double unicorn value this year. We are being used by many of the Fortune 10 customers around the world. So you can see down here great names like Apple, like RBC, like GM, and obviously also being supported by big players like Microsoft and Amazon, as you will see in the next slide. We are pushing a lot for what is called the Open Lakehouse platform. And basically, this is being done by adopting open source standards like Apache Arrow. And you will see later on in the demo how Apache Arrow, which is the in-memory columnar format that we use at Dremio, enables you to achieve really fast insights. Not only Dremio is using this, since Arrow came to market, this is being downloaded by over 50 million people every month. And this comes to being implemented in many of the new solutions that are in the market. And obviously, because we believe a lot in this data lakehouse concept, we created 2 years ago the Subsurface event, which is a live webinar with more than 10,000 attendees every year, which come to hear about how organizations really perform analytics on these big data lakehouses. So let's talk a little bit about the challenge today. And the challenge that we see talking to any customers is that every customer that we speak today might have a data lake strategy. And that can be an on-prem data lake, whether that's an Hadoop like, or an on-prem like Pure Storage or Min.io, or even some customers have already implemented those cloud data lakes, whether that's an ADLS by Microsoft, S3 by Azure, or Google Cloud Storage, where they would start parking their data. The challenge, obviously, is when you look in the upper part of the slide, when they try to query the data, this obviously is very hard because you cannot just go and connect Tableau or Power BI, as you will see, directly to a data lake. And therefore, what these organizations have been doing across the years is they have been moving their data, building those ETL and ELT processes, and moving this data to a data warehouse in the cloud, whether that's a Snowflake, a Redshift, or Synapse. But that's obviously part of the problem because now you not only get just a portion of the data, but it obviously creates a bigger cost for you because you start creating those data copies and obviously data governance issues. Not only that is that once the data sits in the data warehouse, obviously you need to start building those data extracts, data marts, or cubes in order to access the data. And that is why we call it the pyramid of doom. And speaking to many of the organizations, every change that we would need to make in the report, and let's take Apple as an example, who have been running their supply chain analytics on such an architecture. What they told us is prior to using Dremio is that basically every change they had to make in the supply chain report turned out into weeks or even months to get the data and obviously build the reports, which obviously now with Dremio, we're moving into a much faster way. And we're talking about minutes, as you will see in the demo. So what do we bring into the market? So what Dremio brings is a much simplified architecture, what we call a no-copy architecture. And literally, we don't move any data. So the data resides where it is, whether that is a cloud data lake or an on-prem data lake. And basically, Dremio enables you to connect in a very fast way to retrieve this data. We are also fully SQL compliant, which means that every query that you will perform from a dashboard will translate into SQL language. Obviously, self-service is provided through our semantic layer, and you will see that later on in the demo, which gives you the availability to curate the data, to start building what we call those virtual data sets, obviously putting some governance and making it much easier for the data team and obviously for the end user analyst. So to conclude this first part of the presentation, why are we so successful? And you will see that in the next presentations. Is basically we're achieving much more faster time to insights. Literally, you will see that through Dremio and some acceleration capabilities like reflections, which we will talk about in the demo, which gives you a much faster insights and much faster way to query the data. Obviously, your data engineers become much more productive because now they don't have to work on building those ETL processes. They can focus on the real stuff, which is obviously making sure that the data is in the data lake, and obviously you will access it through Dremio. Obviously, making your data consumers access much easier to this self-service semantic layer, and obviously reducing the data infrastructure. So no need to copy obviously resides in lower cost of ownership, obviously less complexity, and much easier to access the data. So I'll pause here and open it later on for questions, and looking forward to talk to you after the demo.
Thanks, Amit, for this wonderful introduction to Dremio. Let's now see how Dremio manages to accelerate queries by using what they call reflections. So reflections are the main feature to accelerate queries in Dremio. As we can read in this slide, a reflection consists of a pre-computed persisted set of results in a packet format. And to work with this feature, you must know that they are built on top of views or anchor datasets. These are equivalent terms. When a view is used as the source of a reflection, this view is called an anchor dataset. These reflections can be set to be updated automatically upon the arrival of new data, and the update can be made in an incremental way so that you can avoid already computed data. And then reflections are used automatically when a query is run. Dremio has a planner that matches queries with the suitable reflection. Another cool feature of Dremio is that it supports semantic layers to help with data management, apply security with access control, and more things. One thing that is important that you keep in mind is the meaning of the acronyms PDS and BDS that we will be using. You can see them at the bottom left corner of the slide. PDS stands for physical dataset, which is the prime source of all the data. And BDS stands for virtual dataset, which is all the views that we will be building on top of the physical data. And to clarify things, views do not store data. It is with reflections that you build on top of a view that you make the data physical. We can start by creating one view for each table we have in the physical dataset to make the necessary changes on things like column names or types and creating additional fields. Then we can have additional layers for more business-oriented queries. So going back to reflections, there are two types of reflections, raw reflections and aggregation reflections. The raw reflection kind of replicates the data of the anchor dataset with the possibility to sort or partition it by any of the existing fields. That is useful if your physical dataset is in a non-optimized format, such as CSV. And sometimes it can help with range lookups on a field, common joins, and repetitive transformations of a field. Then we have the aggregation reflections. These ones work by selecting fields as dimensions or measures. They store the calculation of the measures for each combination of the dimensions. So they fit the needs of BI-oriented queries. Here we have what fields can be the candidates for dimensions, group by, where in, etc. And for measures, things like sum, count, average. So we will focus on aggregation reflections later with examples, so do not worry if you have not a clear view on this yet. Let's continue with the use case we will be covering this session. This project originates from a client who came to us because the cost of their platform for handling data was becoming incredibly expensive as the amount of data increased. The part of the business in which they need this data consists of a survey. Each time a user completes a survey, some data is sent to their storage. Then they have a dashboard where they can have the data displayed in a way that they can extract value. The amount of data we're talking about is what they had is around tens of millions of rows they were storing. And as they create more surveys, more data comes, so they want to be able to handle more. What they are expecting is to be able to scale up to 2 billion rows, and with their current architecture, it is very expensive. Our solution brings cost-effective scalability to allow our customer scale while the BI tool remains relatively small. We achieve this by separating compute and storage by using Dremio as the backend. And Dremio can be deployed in any of the top cloud providers and supports connections with a wide variety of BI tools. If we take a look to their old architecture, we can see an RDBMS as the storage and a BI tool that loads all the data into extracts. That means that the BI tool is acting both as the storing and the computing platform. Scaling the storage for a BI tool may incur in increased costs compared to other solutions oriented to storage. What we propose is to completely separate compute and storage so that we can use suitable software for each of these needs and thus reduce costs. So the solution architecture we suggest consists of moving the storage of the data to a data lake. The one we have chosen is S3, and use a query engine to work with the data. We think Dremio is a perfect fit for that, as it can work directly with the data lake. Finally, to put a name to the BI tool, let's use Power BI and its direct query mode. With this new architecture, we can get cheaper scalability because we are now using a data lake as the data storage, which is a service with that purpose. Moreover, we have no limit of data that we can store in S3, so now we only need to worry about the compute. And remember what I was saying before, the data lake and the BI tool can be replaced by any of the existing software of the same type. We could use a data lake of any cloud provider and whichever BI tool we are most comfortable with. So let's now start focusing on the technical things, starting with the dataset. The dataset consists of a star schema with 17 dimensions and a fact table with 1 billion rows. The fact table is called survey feedback, and there are socio-demographic dimensions such as age, country, date, among others. Let's start with the deep dive into reflections. The first thing we do is a one-to-one view for each of the tables in the physical dataset, and we save them in the staging layer. Within these views, in the staging layer, we can perform some data cleansing actions, such as renaming columns, changing their type, adding a new column, and much more. But these are only views we created. As we have the data stored in the data lake in a CSV format, what we can do is using the view of the fact table in the staging layer to use it as the anchor dataset for a general purpose row reflection. With this reflection, we achieve having the data stored in an optimized format. And additionally, we can select some fields that appear in most of the joins that we have as the partitioning fields. The table you see in the screen is what a reflection will look like when using the Dremio's UI. And this reflection will improve the overall performance of the queries and even the creation of newer reflections. So it is great to have this reflection as a starter in our case. Okay, so what we're going to see in the following slides is a step-by-step guide on how to create reflections. First, we are going to see some ad hoc queries to familiarize with reflections. And after we have understood how we can leverage reflections to improve performance, we will focus on accelerating BI dashboards. So to start building a reflection, we must know what we are going to query beforehand. That is needed because we will be selecting fields as partition, measures, and dimensions. Then it is common that we find a query that has subqueries in it. We must build reflections for the subqueries first and expand afterwards if needed. After the previous steps, we can start building the first reflection by creating first the anchor dataset that will select all the fields that participate in the reflection. And the last step, create the reflection on top of the anchor dataset we just prepared. So here we have a query for the same dataset we saw before, which result shows all the surveys that are 5% longer than the average. To make useful reflections, we must focus on the subqueries. The first one has a count listing operation on the field question ID. The second subquery has an average operation. We'll see why we remark the sum and count operations later. Finally, we have the end of the query, which only selects the fields, nothing special here. We will make 2 reflections, one for each of the previous subqueries. So let's focus on the first one for now. In the first query, subquery, we can see that there are 2 fields being used, survey ID, which is in the group by, and question ID, which appears in the count operation. With these fields, we create a view where we select them and we build a reflection on top of this view, which will be the anchor dataset. When creating the reflection, it will contain the group by field as the dimension and the count listing field as the measure. Among all the options of the measure, we'll select the one we want, which is approximate count distinct. And finally, the view for the first subquery is kept in the business layer with the name of question count. Then for the second subquery, we can see that there is only one field being used, count questions, which is a field that comes from the previous subquery. This field is used in an average operation. That means that we repeat the process of creating a view with the used fields, and then we choose this only field as the measure. This time for calculating the average, we select sum and count. And the last thing we do, we keep this view for the second subquery in the business layer as well, with the name of average questions per survey. Then, having all the reflections prepared, we can now execute the query and check the job history to see that we get around 1 second of execution time for 1 billion rows, and that the job used both reflections we created to finish faster. The names we have just used for the anchor datasets appear under the name of the reflections. Now that we have seen how to create a reflection to accelerate our queries, let's move on to the dashboards with Power BI. Previously to this, and as we just did with the previous example, we must understand the dataset and know the type of queries that we are going to cover with the charts. For example, we know that we will always be filtering by question ID, which is the mandatory filter. That is to make to focus on a single question of the surveys, and we'll also be focusing on the proportions of the answers for each question. In addition to that, charts will be having a filter for the rest of the dimensions in the dataset. And with the following slides, we will keep things simple by focusing on one single chart. We will show the queries generated by Power BI again to compute the chart and what reflections we can create to accelerate them. We will see what happens with the addition of different possible filters, and we will show execution times to be able to compare different approaches when building reflections for BI. So here we can see a chart, the chart in the middle and some filters around it. In this dashboard, we are calculating the proportion of the answers for a specific question, and we are dividing the results by each country. We can guess that the dimension fields will be all the filters we're using, as well as the countries and answer levels by which we are grouping the result. Also, we can run that visual and check that this job is created in Dremio. Then we can create the reflection focusing on this query. What we can get of this query is the key fields that are highlighted, and other than that, we can say that the query looks a bit long and complex due to the joins that Power BI needs to perform. At the end, we are trying to query from 18 tables. The issue here is that this is the query from the previous chart without using any of the optional filters. If we wanted to apply more filters to the chart, we would have a query with even more nested subqueries, and this could be problematic. Another thing worth considering is the current time it takes to run this query without any extra work, just as we have everything by now. You can see in the top right corner of the screen, it takes 18 seconds. Let's see why having complex queries can be problematic. As we mentioned previously, one of the phases that each job in Dremio has to go through is the planning phase. Here, among other things, the query is analyzed to seek a matching reflection that can accelerate it. And when we have queries with high complexity, the planner may not fully check its structure and might not match the most accurate reflection in order to save time. This is a problem for the query we just saw because it has a lot of layers of subqueries. And as we apply more filters, it will have more subqueries. So one solution we thought of is joining all the data in a view and querying to that view from Power BI instead of having the 18 tables model. As this join will be a view, no data is being replicated, and we can take advantage of this to lower the complexity of the query. So that's what we're going to do. We create a new view that joins all the tables. We save the view in the layer we think most fits the query, and we change the data source from Power BI to target the new view, and we saved in this case in the processing layer. When plotting the chart again in Power BI, we get this query sent to Dremio. We can see that we are querying from the virtual join of all the dataset in the line that says from processing.allJoin. For the highlighted fields, we have the survey ID field as the aggregated field inside the count operation, and the other highlighted fields as the dimensions disappear in the restrictive workflows and in the group by. So this query is much more simple than the one we had before. So the same way we did before, we create a view to have a reflection with these fields. Then we select each of the fields as the dimensions or measures. And finally, we run the query again and check the job history on Dremio to see that the reflection is being used, as well as the time it takes to be executed. In this case, we see it takes 5 seconds to execute the query, which is compared to 18 seconds we had before, much more faster. Although this has been successful, there is another thing to consider if we wanted to apply some of the optional filters to the chart. For example, in the right side of this image, we can see that we have selected the age, gender, and nationality filters. Once Power BI starts the request to Dremio, we end up with a query like this with the previous filters. And it is similar to the one we had before, but it contains more fields in the workflows. One could think that we could solve this by changing the previous reflections and adding all the possible filters as dimensions. So we would have an aggregation reflection with all the 17 dimensions. But if we did that, Dremio would calculate the measure of the reflection for all the combinations of the dimensions. That means the reflection would take long to finish, but not only that, by putting so much data into a single reflection, we would be limiting the parallelism that Dremio uses to resolve queries. We can check that if we do this, the job ends up with 23 seconds dashboard. So adding this, that is adding the age, gender, nationality, all these 17 filters in the same aggregation reflection. So instead of this large reflection, we can keep the smaller aggregation reflection for when we do not use additional filters, but we must avoid using an aggregation reflection with so many different values. What makes an aggregation reflection worse in performance is having high cardinality fields as the dimensions, or simply having lots of dimensions. If we run this query again without using the last giant aggregation reflection, we will see that the raw reflection we created at the beginning is covering the query. We can see that it lasts 8 seconds and that the reflection being used is the general purpose one we just saw. And there's more to this. We can go deeper into the details of a job in Dremio and see how it was planned. Here we have the plan for the job of the aggregation reflection with all the dimension fields. It is a single thread of tasks. This is for the same plot with the same filters. The only thing different is that we use the giant aggregation reflection. And in contrast, we have the job for the last approach, the one that runs the same query, but with no aggregation reflection. Here we can see that Dremio plans it with a multiple thread of tasks, and it uses all the one-to-one row reflections from the staging layer. So we have seen that there are some things to consider before creating reflections, and we cannot just start creating them without progressive planning. And the last thing we want to show you is a short recorded demo we have about these concepts we have exposed during the presentation. We think it can be useful to bring you closer to a hands-on experience with Dremio, and you will see where we can locate all the features we used inside Dremio's UI. Let's now continue with a short demo of what we just saw. Starting with Dremio's UI in the main menu, we can see our data lake source on the lower left corner of the screen, which is S3. We also have all the layers for the virtual tables on the left side of the screen. If we go inside the staging layer, for example, we can see all the one-to-one virtualizations we made from the data source and where we perform the last changes of the data. We can click on survey feedback, which is the virtualization for the fact table, and we can see the original SQL from which the table is created. All these changes don't need to be done manually. For example, if we wanted to convert this field into another type, we can do it so by simply clicking on the arrow here, selecting convert data type, and selecting the type to which we want to convert this. There is also the reflections tab, where we can manage all the reflections for this virtual table. In this case, we have the general purpose reflection. This is this reflection we created at the beginning of the project. Here we want all the fields to be part of the reflection, so we are selecting all of them as a display field. There is also the partition field, where we select all the fields that participate in the most common joins. We can also get back to the main menu and take a look at the processing layer, where we have the giant join. Here, we can see also the SQL code, but let's get directly to the reflections tab, where we can see the aggregate reflections we have there. Here we have the aggregate reflections for the dashboards we have in Power BI for when they only use the mandatory filter and not the additional ones. Because remember that we want to use the general purpose raw reflection when using multiple filters to get the query parallelized. Let's now move on to Power BI and see what we got here. We have the 3 dashboards, but let's keep using the one we are familiar with. You can see that the dashboard is being computed. We only have the question ID filter. And we can see that the chart is now filled with data. Let's check Dremio's job history to see what happened. We select the last job that was executed, which is this one. And here we can see the query that was generated using these filters, which is only the question ID filter. And we also can see the reflections used, in this case, the single aggregate reflection. If we check the execution plan, we can see that we are only using one single thread because we are using this giant, let's say, join with this aggregate reflection. If we were to use more filters, for example, an age, year, some gender, and a nationality, now the query is being sent to Dremio, and it is going to be computed in a few seconds. So once we see this, here we go, this data changed, we can go to the job history again, and we can check this last job that was executed in almost 9 seconds. And we can see now that the filters has changed into these ones, and that we are using now several row reflections. We have the general purpose reflection that we mentioned that we were using. So if we check the execution plan, now we can see that there are a lot of tasks and these can be parallelized. So here Dremio can really shine. There are many other things to check here in the job profile of a query, but we won't dig deeper into this today. Let's get back to the presentation. So, okay, let's move on to the conclusions to consolidate what we have learned from this use case with Dremio. The most general things to keep in mind are related to the use of the right architecture for your data. Things like separating compute and storage are healthy practices that are being applied nowadays. By doing this, you can scale each of these independently, and often it leads to reusable structures that do not rely on a specific service. Dremio is a perfect example for that, as it works directly with data lake, but remains isolated when it comes to scaling to allow that cost-effective scalability and compute. Another thing, another great thing is that it is not tied to a specific provider. You can build Dremio in different clouds using different data lakes as the data source and connecting it to a wide variety of BI tools. Regarding the most technical concepts, here there are the main points you should remember. There is no better reflection between raw and aggregation reflections. They have different purposes. Raw reflections, though, are a must when we do not have the data stored in an optimized format, such as Apache Parquet. As for the aggregation reflections, we should avoid using one single reflection for all the possible dimensions we have. It offers better performance to have small reflections, and we have seen that using the first raw reflection offers lower execution times than using the giant aggregation reflection. But beware, because having a lot of reflections that perform similar calculations may cause the planning phase of the query last longer. That happens because the matching of the queries with reflections is held during this planning phase, and having more possibilities to analyze means more time to find the most suitable one. And the last thing, we have seen a useful way to prepare data to lower query complexity by joining it in a single view. This will make all the filters be applied in the same subquery from the BI tool, and will list the development with reflections and their detection by the planner. So to finish with this presentation, we want to add that we have just released the first block of 2-block mini-series about Dremio. Tomorrow we'll have the second part, and we hope you can, if you have further questions about this, and we hope you enjoyed the reading.
Thank you for your attendance. Thank you, Wolfgang, Oscar, Alex, as well as Amir, and hope to see you soon in the next session for our webinars. Thank you very much.